Okay, let's look at a couple of these in the homework. Let's start with number 2. Suppose a simple random sample size n equals 36 is obtained from a population with a mean of 87, standard deviation 24. Describe the sampling distribution of x bar of the mean. Okay, so we have n equals 36, so this is going to be a approximately normal. From the central limit theorem, we know if n is bigger than 30, it's going to be normal. Check answer. That's correct. We'll continue to part B. Find the mean standard deviation of x bar. So the mean is just 87. It is the sample mean. But the standard deviation, right, we have to take sigma divided by root n. So in this case, it's going to be, I'm not sure if you can see that, 24 divided by the square root of n, which in this case is 36. Okay, so now we're going to do the find when the mean is greater than 94.4. And again, pay attention to these little things in blue. Round to 4 decimal places as needed. Okay. So picture, hopefully you're drawing a bell curve with these. It's hard for me to do that in this setting, so I'm not going to. But picture a bell curve, and we're going to do the left. Remember, we're going to do normal CDF. So second distribution. Let me scroll down here. Number 2. And the left bound, it's greater than 94.4, so that's my left bound, right? So 94.4. Right bound is infinity, 1e99. And then the mean, which is 87. Standard deviation, this is where a lot of you are missing it. It's not this 24 up here. It's the 4 that we just found. It's the standard deviation of the sample mean. That's what that sub x bar means. So 4, and then press enter. And again, so we're going to round this to 4 decimal places. Some of you just putting 0.03 in there. Pay attention to these instructions. 0.0322. And again, if you're doing a bunch of these at once, we can set that mode to round to 4 decimal places. And let me redo that real quick. And that saves us from having to round sometimes. Just make sure you go back and redo that when we get off of these problems. Okay. Where's x bar less than or equal to 77.4? So distribution, normal CDF, left bound this time we're going to negative infinity, right? So negative 1e99. And again, you need to be drawing these out. Comma 77.4, comma 87, comma 4. And again, it's going to take doing maybe 10 of these, and they'll become really easy for you. 0.0082. Okay, in between 83.8 and 96.8. So we'll do normal CDF. Left bound, 83.8, comma right bound, 96.8. Comma mean, which was 87, comma 4. .7810. And there we go. Look at number 3. Number 3 is exactly the same as number 2, so we won't do that one. Number 4. Okay, let's look at number 4. Describe the sampling distribution of p hat, assuming the size of the population is 25,000. N is 500, p is 0.3. Okay, so because we have such a large p here, n is less than 0.05 of the total population, right? And n times p times 1 minus p is certainly greater than 10. If you don't believe that, you should go ahead and check that. So n, which is 500, times p, which is 0.3, times 1 minus p, which is 0.7. And it's 105. Okay, then the B part, determining the mean of the sampling distribution of p hat. And that's just going to be p hat, or p, sorry. And this is the tricky one, right? And it's a formula. Again, don't bother memorizing it. If you did about 10 of these, you'd end up memorizing it, but if you can just put that on your note card, if I'm still allowing that. So we're going to do the square root of pq over n, or p times 1 minus p over n. So p is 0.3 times 1 minus p, which is 0.7, divided by n, which is 500. And then close your paren. It says run to 3 decimal places, so be careful here. I've got it up to 4, so we're going to do 0.0. And in fact, that 5 may have been a 4, so let me take that back and do mode. And we'll just go ahead and have the calculator help us round. Yes, that's what I thought. 0.020. Okay, then this last one. Suppose a simple random sample of size n equals 1,000 is obtained from a population n is 1,000,000 and whose population proportion with a specific characteristic is 0.65, completes parts A through C. Okay, so this is going to be approximately normal, and we definitely need to find what the standard deviation of the p hat is. So we're going to do square root of p, which is 0.65, times 0.35, right? 1 minus 0.65, divided by n, which is 1,000. So we get 0.015. Now, if I rounded that back to 4, normally I just float this out. 0.051. There we go. Okay, what the probability of obtaining x equals 690 or more with these characteristics. Okay, so again, we're going to do a normal CDF. Normal CDF. Left bound, so 690 is my left bound, comma right bound, which is the infinity. And then we go out to the mean, comma standard deviation that we just found, 0.0151. And I get 0. Hopefully I didn't put that in wrong. Nope, didn't like that, so let's take a look. See what I did wrong? I went too fast here, right? If I had drawn this curve out, I definitely would have realized it, and that's why I still draw these out. It's just hard to do technologically right here. I need to convert that 690 to a proportion, right? So it's 690 out of 1,000. So let me just go back here, and let's convert that 690. I'm just going to go ahead and insert divided by 1,000. There we go, that looks a little better. So 0.0, and we're doing the 4 decimal places, 0.0040. Good. Okay, so now we have another one. Probability of obtaining x equals 620 or fewer. So we're going to do normal CDF. Left bound, which is the negative infinity, right? Negative 1 E99, comma right bound. I'm not going to make the same mistake twice, so 620 divided by 1,000. And that's easy enough, that's 0.62, right? But just to show you it can be done that way. And then 0.65, and the standard deviation. Whoop, I left off 0.0151. 0.0151. 0.02. And we're doing 4 decimal places. 3, 5. And there we go. So I hope this helps you.